Hello everyone. So welcome to one more video in which we are going to use KVL and KCL to solve the problem. So the problem is right there on your screen. So you can just have a look at the question and you try to answer it by yourself, and you can later compare the answers with my answers. Okay, so what is the question? So in the circuit shown below, find the voltage across the switch when it is open and find the current to the switch when it is closed. Okay, so you see this kind of diamond shaped network is called a bridge circuit or a bridge network. So why it is called bridge? Because this is like a bridge between these two branches. But anyway, right now let's consider S to be open, and our objective now is to find the voltage across this switch. Now whether is it voltage of this point with respect to this point or with this point with respect to this point, that is not mentioned in the question. Just simply question is voltage across the switch. So we'll take the magnitude of the voltage. Maybe this is higher voltage and this is lower voltage, or this may be lower voltage, higher voltage, and this may be lower voltage, or both of them may be equal voltage, and the potential difference between these 2 points may be zero also. That happens when the bridge is balanced, but right now looks like the bridge is unbalanced. So let's see what it is. Now when the switch is open, it's just simple 4 resistances in 2 parallel branches. So it is simple. So let's see. So the circuit can be when S is open. So I have a simple circuit like this. So it will be $20. This is 6 ohms and 4 ohms, and this is 3 ohms and 10 ohms. So I'm sorry, I did not when I draw the circuit, I did not keep the circuit in focus, but anyway, right now you can see. So these two circuits are basically same, and now my objective is to find the voltages of these 2 points. Okay, so between A and B. Now the potential of this with respect to this is 20. So the total resistance is in this branch 10 ohms. So current will be 2 amperes here. Okay, so that is exactly simply 20 divided by 10 will be 2 amperes of current will flow in this branch, and the current in this branch will be 20 by 13. Okay, so let's see what that number is. So 20 divided by 13, so I'm getting 1.538 or 1.538 amperes as my current. Okay, so now I can find the potential drop. Okay, so but then if I consider this as my reference, so from here I can find the gain in the potential. So if it is 0, or I can simply see voltage of A with respect to B, I will say apply KVL from B to A. Okay, so I can take the down route or up route, any route. So let's see, from B I'll go like this. Okay, so from B, at this point I'm there. So if I go up, that means I'm going against the current, so I'm gaining my potential. So 3 into 1.538. Okay, so into 3, so that is 4.615. Okay, so from here I'll go up, so it is plus 3 into 1.538, so which is 4.615. now I'm here. From here I go down 6 into 2, 12, so minus 6 into 2, so that is nothing but 12. 4. Let me get the line in focus. So 4.615 minus 12, so this is minus 7.384. Okay, so this is the answer. So the potential of point A with respect to point B is, potential of A is lower than the potential of B is at a higher potential. So in case if the switch is closed, the current would flow in this direction. Okay, so this is the answer. So so the first answer is 7.384. or 7.8384, correct. Now this is the answer for part A. Now we have part B, find the current to the switch when it is closed. So now when the switch is closed, what is the current? Okay, so let us find that. So for this again we need to redraw the circuit. The circuit is like this. So now the switch is closed. So the above two branches, now it is closed like this, and then below two branches are like this. And then here I have 20 volts. So this was 6, 3, and this is 4 and 10. Okay, so let's confirm that. Okay. So now if you see, what is the potential of this point and how much current will be flowing in this? Okay, so that is the question. Now here, how do we do it? What we need to do is we need to find first the overall current. Okay, so how do you find the overall current? So here 6 and 3 are in parallel, 4 and 10 are in parallel. So 6 parallel 3 plus 4 parallel 10. So this is my total equivalent resistance. Okay, so first let me calculate that. So 6 into 3 is 18. 18 divided by 9. Okay, so that is 2 ohms plus 4 into 10. That is 40 divided by 14. So 2.857. Okay, so the total resistance is 4.857 ohms. Now what is the total current? Okay, so the total current here will be I total equal to V by R. So 20 by 4.857. So I'll get so 4.118. Yes, I'll round it off to 3 decimals. So 4.118 amperes. This is the total current. Okay. So now we need to find the breakup of that current. Okay, so in order to find the breakup of that current, see, because this is a short circuit, the potential of these both points will be same. So first I need to find the potential of this point. So how will I find the potential of this point? See, this is equivalent resistance is 2. So this if I redraw the circuit once again, it will be like this. 2 ohms and 2.857 ohms, and this is the point. Okay, so this is 20 volts, and the current also is known, 4.118 amperes. So the potential at this point will be 20 minus 4.118 into 2, or simply 2.857 into 4.1, because this, if I consider this as a ground, from here to here I'll know the potential of this point. Okay, so let's calculate that. So let's call this as Vm. So Vm equal to, with respect to this 0, so 2.857 multiplied by 4.118. Okay, so I'm getting something like 11.765. So this voltage is here, 11.765. So now given this voltage, and here the voltage is 20 volts. So what is the voltage difference? So given that voltage difference, I need to find what is this current and what is this current. Okay, so let's do that now. So the voltage difference will be, so let's call this as V. This is Vm, and let's call this Vx. Okay, so Vxm, voltage of x with respect to m. Okay, so that will be nothing but 20 minus this number. Okay, so minus 20 I will do. So I'll getting I just did the reverse, so 8.235 is the answer, 8.235 volts. So this is the voltage between these 2 points. So how the current of 4.118 will be separated between these two? So simply this divided by 6 will give me this current, and divided by 3 will give me this current. In fact, I could have used the current division principle, Now I am getting that idea, but anyway, so since we calculated this, let's do that. So let's call this I1 and I2. So I1, I2. So what is I1, I2? So I1 is 8.235 divided by 6. I2 is 8.235 divided by 3. Okay, so I'll be getting divided by 6. So 1.372 and 8.235 divided by 3, 2.745. Okay, so I'm getting this current. Now I got I1, I2, but this I want to find out. Okay, so now again I need to do the similar activity here. So 11.765 divided by 4 will give me this current I3. Okay, so let's call this I3, I4. Okay, so what is I3? So I3 will be 11.765 divided by 4. Okay, so let's do that. 11.765 divided by 4, 2.941 amperes. Okay, so here I am getting 2.941 amperes. So from here the current in this I1, what was I1 value? So I got 1.372. So 1.372 started from the top, and by the time I come here it became 2.941. That means I which joined here will be the difference between these two. Okay, so 2.941 by applying KCL at VM. So 2.941 minus 1.372 is our answer. Okay, so when the switch is closed, I equal to 2.941 minus 1.372. Okay, so minus 1.372. So 1.569 amperes. So this is our final answer. Answer to the B part is 1.569 amperes. Okay, so when the switch is closed, this much current will be flowing from right to left. And similarly, when the switch is open, this much voltage will be there, where the right side will be the higher voltage. Okay. So there's just one more way to confirm our answer. So you find out what is the current in this branch. Okay, so in this I4. Okay, so what is I4? So again, I will write here I4 11.765 divided by 10. So 1.1765. Okay, so is the current here. So whereas I2 was 2.745. So 2.745 started here, and then by the time it come here it is 1.1765. So that means the difference might be going towards left. So 2.745 minus this I have to do. Okay, 2.745 minus 1.1765. 1.1765. So I am getting 1.5685. Now if I go back and check with my actual answer, so 1.569, 1.5685 it's equal, it's matching because of a rounding error we are getting this difference, but otherwise it is matching. So this is the other way of calculating the current. Okay. So I hope you learned something from this problem. Slightly complicated, but still it is interesting. So let's see if we can find some more problems. See you in the next video. So this is a playlist on KVL and KCL, how you use KVL and KCL to solve the simple DC network problems. Thanks for watching this video. If you like it, press like button and subscribe to my channel. Thank you.